So, dear students, now I am going to discuss milling, which comes under Module 5. So, in Module 5, I have already discussed the lathe part. So, now let's see milling part. So, now what is milling? So, milling is a metal removal process in which a workpiece is fed to a revolving tool, thereby removing the excess material. So, if you remember lathe, so what is lathe? It is a machine tool in which the stationary tool is fed against the rotating workpiece. But in milling, so the workpiece is stationary, but the tool is rotating continuously. Okay, that is what the difference between milling and lathe. So it is a metal removal process in which the workpiece is fed to a revolving tool, thereby removing the excess material. Again, here we are going to remove the excess material and to make a final product as like lathe. Okay, so now milling machine. So what is milling machine? It is a power operated machine tool where the workpiece is firmly clamped and is fed against the rotating milling cutter to get the required shape and size. So this is the definition of milling machine. Difference between this lathe and milling is, so in lathe we fix the tool and workpiece will be rotating. Okay, so we feed the fixed tool against rotating workpiece, so we will get the metal removing. So but in milling process it's reverse. So what happens here? So workpiece is stationary, tool will be rotating. We will feed the workpiece against rotating tool. Okay, so here, so whatever tool we use, we call it as milling cutter. We call it as cutter, so that is called as milling cutter. Next, let's see principle of milling. So in principle of milling, you can see here, so here the cutter, what is this? Milling cutter will be rotating. So this rotating in anti-clockwise direction. Okay, so the workpiece is firmly clamped on the work table, then it is fed against the rotating cutter, so we will get the some metal have been removed and we will get the final product. So here there are two types of milling. One is up milling and one more is down milling. Let us see what is up milling. So if the workpiece is fed in the direction opposite to that of the cutter rotation, okay, so this process is called as up milling, or it is also called as conventional milling. So what happens here? The workpiece is fed opposite to the direction of the cutter. So the cutter is rotating in the anti-clockwise direction. We are feeding the workpiece opposite to that of rotation of cutter. Okay, so this we call it as up milling. So what is down milling? If the workpiece is fed in the direction same as that of the cutter rotation, this process is called as down milling, or also called as climb milling. So this is also called as climb milling. Okay, so this is called as conventional milling or up milling. So here what happens, you can see the cutter is rotating in the clockwise direction and the workpiece is feeding in the same direction, which is the milling cutter of that milling cutter. So this is called as down milling. So hope you got the difference. So during up milling, what happens? We feed the workpiece opposite to the rotation of the milling cutter. So that is called as up milling. In down milling, we feed the workpiece in the same direction of that of the milling cutter. That is called as down milling. Okay. Next, see what is the difference between or comparison between up milling and down milling. Okay. So the first difference is workpiece is fed in the opposite direction as that of the cutter. This I have already told in the definition. So here in down milling, workpiece is fed in the same direction of that of the cutter. Okay, so this is the first difference. Next difference is Chips are progressively thicker. Chips are progressively thinner in down milling. In up milling, the chips. So what is chips? So chips are nothing but when we cut the material, okay, with the help of cutter, the metal which is removed from the workpiece will be in the form of chips. So that we call it as chips. So here, whatever chips obtained from the workpiece is thicker, so here it is thinner. Okay, next, third difference in between up milling and down milling. So strong clamping is required since the cutting force is directed upwards to tend to lift the workpiece. Yes, obviously, if you feed the workpiece against the rotation of the milling cutter, what happens? There's a chances of lifting the workpiece up. Okay, so here we should clamp the workpiece very strongly, but here that strong clamping is not required. So since we are feeding the workpiece in the direction of milling cutter, so there is no need of means strong clamping is not required because it will press the workpiece in the downward direction. Okay, next, in up milling we get the poor surface finish. Okay, so since this is chips gets accumulated in the cutting zone, so during the up milling process the chips are accumulated in the cutting zone. Due to this, the surface whatever we get will be rough or poor surface finish. So in down milling we get the good surface finish because the chips have been thrown away during the cutting process. Because so what happens, it is we are feeding the workpiece in the direction of milling cutter, so the whatever chips formed will be thrown away. Okay, so here we will get the good surface finish in down milling. Next, coming to up milling, so it is used for odd materials. So up milling is usually used for odd materials, and down milling is used for soft materials. Example, hard materials may be cast iron, okay, or stainless steel. Soft materials may be like non-ferrous metals like aluminum and all. We can go for down milling operation. Next, moving to next topic, that is types of milling machines. Okay, so what are the various types of milling machines? So according to construction and working principle, the milling machines can be classified as follows. So first one is column and knee type milling machine. Second one is planar type milling machine, and third one is profile cutting milling machine. Last one, special purpose milling machine. Okay, so here there are four main types of milling machines are there. Okay, so in this column and knee type milling machine, planar type, profile cutting, special purpose milling machine. So coming to your syllabus, we are having two milling machine. One is horizontal milling machine, vertical milling machine, which comes under column and knee type milling machine. So let us see. So what is the working principle of horizontal milling machine and what is the working principle of vertical milling machine? Okay, with the sketch we can see this one, how it works and all. Now first let us see the first one, horizontal milling machine. So what is this? So this is the horizontal milling machine. So why the name horizontal and vertical? I will tell this. So the spindle, okay, where the milling cutter has been mounted, based on that position of that spindle, we are going to means divide it as or categorize it into horizontal and vertical milling machine. In horizontal milling machine, you can see the name. This is arbor. This is the spindle, or arbor is connected to the motor spindle. So it is placed horizontally. So this is called as horizontal milling machine. So when I come to vertical, I will show how this spindle has been mounted. Exactly, it is mounted in the vertical manner. Now let us see horizontal milling machine. Okay, so this is the diagram of horizontal milling machine. You can see it consists of number of parts, like first one, base, column. So this vertical section we call it as column. So this is the base. The column is attached to this base. Then this is control panel to switch on and switch off the means machine, this vertical milling machine. Next, this is overhanging arm, this one, and this is a bracket which is attached at the other end of the overhanging arm, so which supports this arbor. Okay, so one end is connected to column, means connected to motor, so motor is placed in the column, so this is arbor. Next, coming to here, so you can see this one, this is called as lifting screw mechanism, and this is knee, this portion is knee, and this one, you can see this one, above the knee we have saddle, so above the saddle there is a work table, and this is milling cutter which is mounted on the arbor. Okay, so now one by one let us see. So this is a base, so it is made up of usually cast iron structure which is hollow and is an integral part of column. Okay, so it is a hollow port and it is an integral part of column. So next, column. So column, which is an integral part of the base, is made of hollow cast iron. So this is hollow, this is rigid one. Okay, hollow. It houses the main drive, transmission, spindle, transmission and spindle, etc. Okay, you can see here. Here there is a motor will be placed in this hollow column, and there is a control mechanism. This is also mounted here. Okay, so this column houses motor, then transmission system as well as spindle. Okay, the front face of the column is machined and provided with a vertical guide. You can see here there is a guiding mechanism to lift the workpiece up and down. Okay, so where this guide is connected, the knee is attached to this guide. I will tell what is knee and all. Okay, so this one, next part is knee. It is a cast iron part which slides on the vertical guideways of the column. Okay, so this one, as I told, the knee, this one slides in the vertical guideways which is placed on the column. Okay, the sliding is done by the elevating screw and knee elevating handle. You can see this one. So this is the handle. If we rotate this one, this can go up and down with the help of this lifting screw mechanism. Next is saddle. So saddle, this slides on the knee by operating the cross feed handle. So you can see here one more handle is there. If you rotate this one, so this saddle is supported by the work table. If you rotate this one, what happens? It will move in this manner. Okay, so knee up and down, this will goes to and fro. Okay, it is used to feed the workpiece against the rotating milling cutter. Okay, next is table. Table is mounted on the top of the saddle and moves on the guideways. The table is provided with T slots for mounting machine. Okay, so mounting the workpiece. The movement is done with the help of this rotation. Next is overarm. As I already told, so this is the overarm. This is made up of cast iron mounted on the guideways provided on the top of the column. Okay, this also supports the guide and the other end. As I told, this bracket is connected to this other end of this overhanging arm. Okay, so next is arbor. So it is a shaft with a tapered like structure where to fix the milling cutter we use this arbor. So this arbor is connected to the main shaft of the motor. Okay, when we switch on, the motor starts to rotate, then the arbor will also starts to rotate. Okay, so now let us see working principle. So here the milling cutter is mounted to this arbor. Okay, when we switch on this, motor starts to rotate. So when the motor starts to rotate, this arbor starts to rotate and the milling cutter is attached to that. Meanwhile, this milling cutter will also rotating continuously. So now what happens? We have to fix the workpiece here and we need to feed this workpiece against rotating milling cutter. So what happens? the cutting of the workpiece taking place, and we can get the final product. Okay, so horizontal milling machine used to produce keyways, grooves, gear tooth, okay, and then spline in shaft, etc. Okay, so this mainly used for cutting of this gear teeth. Okay, even in the maybe you have observed in the shaft there is a small groove will be there. Okay, so that also done with the help of this horizontal milling machine. Next we see vertical milling machine. So vertical milling machine, yeah, you can see here, this is the spindle which is in a vertical manner. So you can see here in the horizontal milling machine you have not seen the motor. Motor is placed inside this column, you can see this one, but here you are not able to see the motor. But in vertical milling machine, directly the cutter is attached to this spindle of the motor and it is placed in a vertical manner. This is the difference, one of the difference in between that horizontal and vertical milling machine. Okay, so it is also same. So you can see here there is a base, there is a column, there is a knee, work table, sorry, this is saddle and this is work table, and this is the guideway, and here it is spindle, and this is milling cutter, this is spindle head. Spindle head is nothing but the motor. Okay, so now same thing, the base is made up of a rigid material and this is a hollow portion again. So here we have the controls for controlling the speed and switch on switch off of the motor. Here working principle, what happens here means we can mount the workpiece on the work table. So lift this knee to upward. Here milling cutter, when we switch on means milling cutter will be rotating continuously. If you feed the workpiece against the rotating milling cutter, we can remove the material from the workpiece. Okay, if we remove that material from the workpiece, we were able to get the final product. So this is used, the vertical milling machine is used for face milling and end milling operations. Okay, so here the cutters used is face milling and end milling cutters are used. So this is the working principle of vertical milling machine. Say same here, what happens, all the other parts are remain same, but here cutter is mounted on the arbor in the horizontal manner. That's why it is called as horizontal milling machine. If you come to here, the milling cutter is directly mounted to this spindle of that motor, spindle head. So in the vertical manner, so that's why it is called as vertical milling machine. Now let us see what is the comparison between horizontal and vertical milling machine. So most of them I have already discussed it. So here in horizontal milling machine, spindle is horizontal and parallel to the work table. Okay, so which is parallel to the work table and it is horizontal. But here the spindle is vertical and which is perpendicular to the work table. Okay, so this is the first difference. Here parallel to work table, here spindle is vertical and perpendicular to the work table. Next is cutter cannot be moved up and down. Yeah, so here one function is cutter will only rotate, you cannot move up and down, but here cutter can be moved up and down. Okay, next is cutter is mounted on the arbor, cutter is directly mounted on the spindle. This also I have told. Next difference is spindle cannot be tilted. So here only we horizontal means on the arbor cutter is rotated, we cannot tilt that arbor. Okay, but here in the vertical milling machine the spindle can be tilted for an angle to obtain the angular cutting. Okay, next operations such as gear cutting, plane milling, straddle milling, gang milling, etc. can be performed. Next operations such as slot milling, T-slot milling, angular milling, flat milling, okay, can be performed using this vertical milling machine. Even drilling, boring and reaming can also carried out using the vertical milling machine. Next one. Next, let's see milling processes. See, like in the lathe, we have different operations in the lathe, like turning, facing, thread cutting, knurling, okay, drilling. Even in milling process, milling, we are having the different process. We can carry different processes by using the milling machine. So in that, first one is plain milling or slab milling, end milling, slot milling, angular milling, form milling, straddle milling, gang milling. These are the different types of operations we can do using the milling machine. So let us see one by one. First see plain milling or slab milling. So here you can see here, so this is the milling cutter, this is arbor and this is workpiece. In this process is used to get the flat surface on the workpiece. If I want a flat surface on the workpiece, so we can go for plain milling or slab milling operation. In this process, cutter axis, so this one, cutter axis and workpiece surface are parallel. So cutter axis and this workpiece surface is parallel. This is performed on horizontal milling machine. Okay, so the cutter, this cutter we call it as slab milling cutter. So what happens here? The workpiece and the cutter arbor, that axis is parallel. This is used to get the flat surface on the workpiece. So here cutter used is slab milling cutter. Again what happens? This will be rotating. We will feed the workpiece against the rotating cutter. So we are going to get the flat surface. Next one is end milling. So this is end milling. Again this is a workpiece and this is a end milling cutter. So maybe can you guess this, which machine is used? Is it vertical or horizontal? Yeah, this is horizontal, means we can perform this one using vertical milling machine, not horizontal milling machine, since the axis of this spindle is vertical. Okay, this process is used to make slots, keyways and pockets on the workpiece. Okay, so this is used to make the slots, keyways, pockets on the workpiece. Here the cutter axis is perpendicular to the workpiece surface. So in the plain milling, what it was horizontal, but now here it is vertical to the workpiece surface or perpendicular to the workpiece surface. This is performed on vertical milling machine. The cutter is called as end mill or end mill cutter. Okay, so this has cutting teeth, you can see here. So here on the surface also it has teeth, on the bottom also means end, here it has also teeth. If you feed the workpiece against rotating the spindle, so what we will do, we can produce the slots here. Okay, next one, slot milling. Okay, slot milling, this is a process to make slots on the workpiece. Okay, slots, it may be rectangular or it may be T slot or it may be dovetail slot. We can use here both horizontal as well as vertical milling machine depending upon the type of slot we required. You can see here, so this is the workpiece and this is the arbor. The side and face cutter, which cutter this one? Side and face cutter is mounted on the arbor. So we are getting here is rectangular slot. This is performed using horizontal milling machine. If you come to here, T slot, you can see here, this is the final means product after the operation. So here this is a T slot cutter. This is obtained by using the vertical milling machine. This is performed by using vertical milling machine and this is performed using horizontal milling machine. Again same thing, the cutter will be rotating, will feed the workpiece, stationary workpiece against rotating cutter, will get this rectangular slot. Same thing here, in the vertical milling machine T slot will be rotating, T slot cutter will be rotating, we feed the workpiece against rotating cutter, so we'll get the T slot. Next one is angular milling. So angular means, you can see here, there is some angle. If I want to produce a product with some angle, so we go for angular milling cutter. Okay, so it is a milling operation to get flat and angular surface on the workpiece. Okay, this is performed using horizontal milling machine. So this is angular milling. Next one is form milling. So what is the next one? Next one is form milling. So what is form milling? Form milling is an operation to get a curved profile or contour like concave or convex shapes we can obtain by using this form milling cutter. You can see here. This is the curved profile which is obtained on the workpiece. So this cutter is called as form cutter, again which is mounted on the arbor. It is performed using horizontal milling machine. So this form cutter will be rotating. We feed the workpiece, stationary workpiece against the rotating form cutter, will get this curved profile on the workpiece. So this is called as form milling. So next one, straddle milling. So what is straddle milling? It is an operation to get two parallel surface machined simultaneously on the workpiece. Suppose what we can do here. So if I want a workpiece which is means both the sides of this workpiece should be what? Should be parallel. So what I can do? I can do with only single cutter. First I will do the first face, this face, right hand face. Then I will reverse this workpiece. Then I can go for second. So this face. So but if I use two cutters at a time, two side and face cutter at a time, what we can do, at a single run, at a single cut, I can perform both the side operation. Both the side, the operation can be carried out with the help of two cutters at a single time. Okay, instead of doing one end first time, then reversing this workpiece on the other end next time, place the two cutters, then obtain the means do the operation at a single run. So what happens by doing this? We can save the time and we can save the energy also. More workpieces means more products can be produced. So this is nothing but straddle milling. Okay, two parallel surfaces machined simultaneously on a workpiece. This is carried out on an horizontal milling machine. Okay, so here two side and face milling cutters have been mounted on the arbor. At a time both the operations can be done. So this is called as straddle milling. Next let us see last one, that is gang milling. Maybe if you see this diagram, you may confuse with straddle and gang milling, right? Yeah. Notice this one. The difference is here spacer is provided. This is not the cutter. What is this? There is a spacer between two side and face cutter. This doesn't do any operation. But if you come to gang milling, you can see here these two are side and face cutter and this is slab cutter. Even this one will also do an operation. So what is gang milling? It is a process to get different profiles on the workpiece simultaneously with different cutters at one stretch. Okay, so what we can do, we can fix the different milling cutters. Okay, so fix the different milling cutters and obtain the different profile in the workpiece in a single run. So that we call it as gang milling. So there are several shapes we can get it. So here the simple shape. So here I have taken two diagrams. One you can see, one is slab cutter and these two are side and face cutter. So here which are the operations we are doing? One is slab cutting and one more is side and face cutter. So in the single run I am doing the two operations. One is side cutting and one more is plane cutting. So this is called as gang milling. You can come to this diagram. See here also we are getting the different profile. See this one. Here it is completely plain surface. Here you can see there is a slot like structure also we are getting. So this is the final product. So what we can understand from this is, in the gang milling we can place the different milling cutters. During a single run we can perform various operations like you can see in this diagram. One is side cutting operation. Here it is planing or flattening the surface. Here you can see the slot, rectangular slot is produced. So this is called as gang milling. Don't confuse here. Gang milling is by using the different milling cutters we can do the various operations in a single time. But in straddle milling, single operation with two cutters, okay, has been done. So this is about milling part in the module